Okay, so the topic is confined spaces. What is a confined space by definition? Okay, what is a confined space by definition? Every confined space has its own characteristics. Okay, so it is a space. It is a space. Confined space is a space which has limited access and egress. Okay. Second one, it is not meant for continuous human occupancy. Okay, it is not meant for continuous human occupancy. Second thing, it might contain, okay, it may contain flammable or toxic atmosphere. Okay. Second, it may have oxygen deficient or enriched atmosphere. Okay, this is the definition. Finish. So how many points you are looking at is only if the space is having limited access and egress. Okay, that means it is only having one exit or one entry and one exit, or one entry and the same exit. We are not having multiple entry and multiple exits. Okay, it is having very limited access, only one person can go through it. Okay, and it is not meant for continuous human occupancy. It is not meant for human occupancy. Okay. Next is it may contain flammable or toxic atmosphere. So one is we are having limited access egress. Two, we are having flammable. We might have flammable atmosphere. Three, we might have toxic atmosphere. Fourth, we might have oxygen deficiency. 5, we might have oxygen enrichment. So how many points? 5. Keep it in your fingertips. Okay, so these are the hazards of confined space. What are the hazards of confined space? Limited access egress, don't forget the sequence. Toxic atmosphere, flammable atmosphere, oxygen deficient atmosphere, oxygen enriched atmosphere. Finish? Simple? Right. So now we will see. Okay, so what we will see now is what we have to worry about. Okay, what we have to worry about in confined space entry. So before that, what are the examples of confined space? So examples of confined space are storage tanks, vessels, silos, manholes, sewers. Okay, manholes and sewers. Okay, so what we need to do? Okay, first, entry into confined space is very much important. So we have two things. One thing is before entry and second thing is after entry. What we need to do before entry and what we need to do after entry. Before entry, what we need to do is, see, any place, for example, say we are having a tank, we are having a tank. Okay, let's say this is our material in, and let's say this is our material out. Okay, and say there are several other lines coming in and going out. There is a vent. Okay, and here it is out, right? So we will have a small valve here for drain. Okay, drain, or you can even indicate it as vent. Sorry, so we are having valve for drain, and for vent it is just a PRV kind of thing, the relief valve. And here we are having input valve, here we are having output valve, and here again we are having input valve with an actuator. This is an indication of actuator, right? Electrical controlled. Okay, so I mean in P and AD you need to know all this stuff in general, but I am just keeping it very simple now. So before entry, what we need to do is we need to see, okay, whether this particular procedure has been implemented or not. So what procedure has to be implemented? First, the materials inside this particular confined space, the materials inside confined space has to be drained out. Okay, now draining is done, means we have taken out all the materials, but what will be present inside the confined space? There might be harmful gases, oxygen might be less, there might be flammable material. So what we will do is we will first purge. We will purge either nitrogen or argon because it is abundant, it is easily available. This purge gas is either nitrogen or argon. Why we are doing purging? Because this is inert gas, it does not react with other gases, it will just push everything. Okay, so after that what we will do is, now what is left over inside the confined space? Purge gas. Now can person enter into the atmosphere? Why? Because purge gas is inert gas, inert gas is there, means oxygen deficiency is there, we know it. So now what we will do is we will send compressed air, I mean we will just send air, okay, or we will ventilate. Okay, either we will send air or we will provide ventilation inside the space. Okay, once we have provided ventilation, now is it okay for us to enter into the space? So the material is drained, we have purged it, now the space is having sufficient oxygen because air is there. Can we enter into the space? Why? Before entering, so before draining, before purging, before sending air or ventilation, we haven't done important step, which is isolation. Okay, so before starting all this process you have to isolate. Okay, in isolation you have to do positive isolation. Positive isolation means in any case the material of any sort will not enter into the confined space at any point of given time. At any point of time it will not enter into the confined space. So we have to isolate which point? We have to isolate here. So for isolation follow LOTO. Okay, isolate here, LOTO. Okay, isolate here, LOTO. We are just isolating all ins and outs. Okay, isolate here, which is LOTO. Okay, after isolation no material is coming, then we are draining, then we are purging, and we are sending air. Now the place, is it safe to enter or not? Is it safe? Yeah. So after that, before entry, we have to check the atmosphere levels. What levels? Atmosphere levels. Okay. So this is what we have to do before entry, and all these things will be lined up in our permit to work. Okay, all these things will be lined up in our permit to work. So we will see what we will check in the atmosphere levels. Okay, so what we will check in atmosphere levels? Normally a person called as authorized gas tester will do gas testing. Okay, so authorized gas tester will do gas testing. Okay, so here we are having different devices. Yesterday you have already read about automatic gas detectors and all these things, but here we will be only using portable gas detector. Okay, and we will use multi gas detector. Portable gas detector, and in that we will use multi gas detector. We can use individual gas detectors depending on the type of chemicals. For example, if you are working with sulfur, we have to check what is the sulfur content, sulfur dioxide is present or not. Okay, so we cannot check with the multi gas detector. Okay, so we have to use gas detectors as per our requirement. Okay, here in general multi gas detectors we have 4 functions. Okay, we can monitor 4 things. What we can monitor? We can monitor oxygen. Okay, oxygen level always has to be in between 19.5% to 23.5%. Okay, in general atmospheric oxygen is 20.9%. In general atmospheric oxygen the content is 20.9%. A person can work inside the confined space if an oxygen level is in between 19.5% to 23%. And second thing is we have H2S. H2S, it is less than 10 ppm, we can allow the person to work. If it is more than 10 ppm, no work. Why? Because it is as per our TWA. Okay, right. What is the TWA value of CO2? We can measure carbon monoxide, not CO2, sorry, CO, right? So what is the TWA of CO? Yeah, check it. TWA of CO. Sorry? 15. No, 35. Check, check. It is 35 or 50. 50 is STL value. Sure. See, remember one thing, whenever we are looking at TWA values, always take ACGH values as a reference. Okay, ACGH values as reference. Okay, it is 35 ppm. Okay, if it is less than 35 ppm, we will allow. If it is more than 35 ppm, we will not allow, no work. Okay, if it is greater than 23.5%, no work. If it is less than 19.5%, no work. Okay, and here we have LEL, which is lower explosive limit. It has to be less than 10%. Okay, if it is greater than 10%, no work. Okay, less than 10% it is permissible. for us to allow people to do the work. Okay, got it? So if only oxygen deficiency is less, other things are not there. This is toxic and flammable. Okay, this is also toxic. Okay, and this is flammable, right? We are monitoring toxic levels and flammable levels, and at the same time we are monitoring oxygen levels. So if the oxygen level is, the toxic levels are very minimum, like 1 ppm, 1 ppm, flammable limit is 1 percentage, then it is okay to work, but only oxygen levels are not there. So at that time what we will do is we will provide additional oxygen. If oxygen levels are low, first thing is we will ventilate the space, ventilate the confined space, okay, or provide continuous air supply, okay. If there is a continuous air supply, we will have fresh air, okay. So if this is not possible, what we will do is we will provide air to the person. We are not, this is for the space, continuous air supply to the space, but if both are not possible, we will provide oxygen only to the person who is entering into the space. Yeah, so we are having two kind of things, ALA. Okay, so instead of shortcut, I'll just write the full forms. We have airline breathing apparatus, okay, which is just a hood and then compressed air, okay, from a compressor will be supplied to the hood. This is one thing we can do. If we want, the main drawback of this is we are only having limited, we can only cover limited distance, okay, but we have to cover more distance, we have to enter deep into the confined space, and we are not having sufficient, then we will go with SCBA, which is self-contained breathing apparatus, okay. In this we are having oxygen tank, we will carry oxygen tank, and then we will go inside. This oxygen tank also, depending on the volume that we are taking, everything, the time will certainly is a time is certainly a matter of concern, okay. Normally depending on the oxygen level tank, we can only work till maximum of 15 to 20 minutes, okay, in a confined space. If the oxygen tank capacity is more, we can hardly work till 30 minutes non-stop, okay. So this is about gas testing. And where should we conduct this gas testing? Where should we conduct this gas testing? Gas testing should be conducted at 3 levels, okay, inside the confined space. This is a confined space, okay. Gas testing should be carried out at 3 levels. One is higher level, one is mid level, and one is lower. Why? Because there are gases which will sink to the bottom, they are heavier than air, so they will only settle at the lower places, so we have to check at lower point. And second thing is middle point, okay. Some might be more or less equal to air, so it might settle down in the middle portion, and gases which are lighter will just flow on the top. So we have to check at these 3 portions, and then we will have to analyze our results, okay. So this is about gas testing, okay. So this gas testing has to be done before entry, remember, it has to be done before entry, okay. So while entry, what we will have to do before entry? Now while entering confined space, what we have to do? First we have to check if we are having proper permit, okay, and what is the gas test result, okay, what recommendation have been given, what recommendations are being given. Okay, whether do we need a continuous air supply or continuous gas monitoring is required or not, so that we have to see, we have to follow that. Okay, the persons entering the space should have sufficient training, confined space entry training. Okay, and they should always follow buddy system. Okay, not only one person should never be allowed into the confined space. So there should be one whole watcher outside confined space to monitor the space, monitor these two persons. Okay, he will be a person only to communicate. Even in a case of emergency, this person should not enter into the confined space. Okay, instead of that, he should initiate the emergency if the time comes. Okay, that is the responsibility of hole watcher. And second thing, required emergency equipment. SCABA, okay, or tripods to take him out. Okay, so all these things should be easily available. Okay, and there are some other type of apparatus also, EEBA, I mean like emergency escape breathing apparatus, which will be used for 10 minutes. It is not used for rescue, but it is used for escape. Okay, which only has a time limit of 10 minutes. Okay, so all the required safety equipment has to be checked before entering into the confined space. Okay, right. So after entering into the confined space, what you should do? Yes, next. Okay, okay, so after completion of work, okay, so before work, during work, or before entry, during entry, and after entry. Okay, so after completion of work, okay, make sure all employees are out of confined space. So how will we know if all employees are out of confined space or not? So this whole watcher will maintain a log sheet. So in this log sheet, in and out times will be there. So if in and out time for every person is maintained, so we will know that okay, all the persons are out of the confined space. So that is what we will have to take care. And second thing, and make sure, okay, all materials which are remaining are removed. There should be no material left in the confined space. Okay, that means housekeeping should be proper. Should be done. Once everything is done, they will close the confined space. Until then, they will not close the confined space. Once the work is done, they will submit the work completion. I mean, they will submit the PTW for closure. At that time, they will check all these things, and then only they will close the PTW. Without checking, we will not close the permit. Okay. So once this permit is closed, then only that LOTO has to be removed. LOTO will be removed by a separate permit. Okay, LOTO is not interlinked with confined space permit, whereas we will have separate system for that. Okay, so in that system they will go with removal of LOTO. Isolation and de-isolation, that is a different topic, we will discuss that. Okay, so this is about confined space. Okay, right, we will go for the next topic.